Okay, here's a video on using the TI84 for actual ACT imaginary or complex numbers questions. A lot of students don't like these at all, and a lot of them are very straightforward on the TI84. The one thing about complex numbers is generally they're going to be you'll find them most in the 40 to 60 questions. They tend to be the most difficult questions. You sometimes get one that's in, the 1 through 20 range. It's rare, and it'll usually just be adding imaginary numbers. But these are all, it starts at 29, goes to 47. The first two are very simple to do in the TI84 calculators. The third one, the 47 one, we'll need to do, it's a good, the 47 question is a good question type to know, because this question kind of format, not necessarily with imaginary numbers, just with other variables, shows up fairly frequently on the ACT, and I'll explain that once I get to it. But anyway, let's find out how we do complex imaginary numbers on the TI84. Question 29, what is the product of the complex numbers negative 3i plus 4 and negative 3i and plus 3i plus positive 3i plus 4? Right. So we just write it out the way it is right there, right? All we want is, let me get a pen. All we want is negative, we want to put this into the calculator, times 3i plus 4. I always just like to write it out. I just feel like it keeps me, from losing my place. You don't have to. So we get parentheses, and it's going to be negative 3. And to find I, you go to second, you press this decimal point, and up pops I. It's a wonderful thing. Plus 4, close parentheses, we want the product, so that means it's multiplied, times, I need to open the parentheses, I now just have 3, up here second, decimal point, that gives me the I, and it's plus 4. Next thing, last thing I have to do is close the parentheses, and we're looking for 29 as C, so we're looking for the answer of 25. And we got that. Okay, clear that out. 46 isn't much different, but they've just worded it differently. It's going to be 4 plus I squared. So just write it as is. Open parentheses, 4 plus, to get the I, we go second, decimal point, 4 plus I, we close the parentheses, come over here, this button will just put the squared right in there, and we're looking for an answer of J, 15 plus 8i, we hit enter, 15 plus 8i. There we go. All right, the last one. This is a 47 question, so it's up there. When using the quadratic formula, Monali found that an equation had solutions x equals 5 plus or minus the square root of minus 9a squared, where a is a positive real number. Positive real number. Which of the following expressions gives Monali's solutions as complex numbers? I think there's a bunch of students out there that would just throw their hands up and think, oof, this is guessing time. I'm just not even going to try it. But with the calculator and, again, just a little practice with this kind of type of question that you don't freak out with it, we can get it quite easily. So any positive real number, where a is a positive real number. What I would do there is, that means we can plug in a number, a positive real number. So what I would do is look at the answers and see that in the answers we've got 1, 3, 6, 9, 12. So I'd pick one of those. I don't want to choose like a 5 or a 4. I mean, they're all like divisible by, they're all kind of like 3, 6, 9, 12. They're all divisible by 3. So I don't want to choose one because it's not going to show me the pattern clearly enough. In the exam, I would choose 3. But the thing I notice is that B is the answer, and that's actually this 3AI. So it would make it too easy if I picked 3. But in the exam I would. I'd pick the closest number, the smallest number after 1. But for this example, to show you that it works, I am going to choose 6 and show you that it'll work even if you, no matter what one you use, as long as it's kind of in the same line of, it's going to be easier if it's a 1, 3, 6, 9 or 12. Right, so we're just going to put the equation in it as is and do 5 plus, we come over to second and down here, now we'll put in the square root, and we have got negative 9 times, and I'll put parentheses around this so the calculator can separate everything out. We're using A, we're saying A is 6, we've got, I'll write that down, and it's probably a good idea to write down what you're doing. A equals 6, so we've got 6, close that parentheses, come over here to the squared, and then we'll get out the whole thing, and we'll just press enter to get what we have. So that comes to, when it's positive, it's 589. Alright, we've got number 1. But we also have to do the negative. So we're going to do 5 minus the square root of negative 9 times, open parentheses 6, close parentheses, over there for the squared, just move it over, press that. What does that give us? 5 minus 18. 89. So that's what happens. If we use a positive real number, we get this. So now we have to look and say this is a kind of, this is used more than once. We have to look at this and say what one of these satisfies this, right? When A is 6. So we're just going to put in 6 for A. So the first one, A, would be 5 plus 1 times 6i. So that would give us 5, I probably don't want to do it there, 5 plus 6i. Does that equal that? No. Right. B, we get 5 plus 3 times 6 times I. That gives us 5 plus 18i. Does that equal that? Yes, it does. And just to see, does it do both of them? We'll do 5 minus, I mean it does, I mean you can see it, 3 times 6 times I equals 5 minus 18i. Does that equal the second one? Yes, it does. So that's how you do that. You just pick a number for A, following these rules. It's a positive real number. You plug that in, you know, and I say, look at the answer choices to see what's a good number to pick. I picked, you know, one of the, you know, it's a multiple of 1, 3, 6, 9, 12. So I picked 6. I would have picked 3 in the actual exam. But you want to just make sure that you're kind of making it as easy for you to see the pattern as possible. So you want to keep it in line with what the answer choices have and not choose, as I said before, a 4 or a 5 or something like that, because it would be harder to see the relationship. But there you go. That's a 47 level question. If I hadn't blabbed on with the explanation, you would have been able to get it done again in, you know, maybe 20, 30 seconds. And that's pretty sweet when you're dealing with a 47 level question. So yeah, we love the TI84.